Very good evening, friends. Hope so. I'm audible. Yeah. All right, my dear friends. Now, uh, almost the continuation of our answer writing practice, right? So, almost we are there in the sixth session, and today I'm concentrating only on this physical geographic aspect. Okay. So, the salient features of world's physical geography, along with this important geophysical phenomena, right? So, two paragraphs of geography syllabus. Somewhere I'm just covering it. Say for example, the next two sessions what we have will be somewhere focusing on the distribution of natural resources across the world, India, including Indian subcontinent, along with the industrial locations. Okay, right. Now, right, my dear friends. Now, as a matter of fact, 31st July, sociology optional subject is starting. So I'm just providing some of the piece of information regarding the same. So kindly make use of it. So you can almost say, for example, right, use this code Sriram's. Okay. Right, my dear friends. Now, coming to our discussion part, right? Say, for example, even yesterday, we have taken somewhere around 7 questions for the agenda. At least, somewhere effectively, we have completed somewhere around 5 questions. Whatever I have just left in yesterday's paper, right? Whatever I have left somewhere today, I have just taken it, right, for our discussion. Excuse me. Right, my dear friends. Now, the question what suppose means what we were supposed to see yesterday, right? What are extratropical cyclones? Right? Discuss the weather effectivity induced by them. See, always I say as an SOP, as a standard operating procedure, what you are supposed to do somewhere identify that, say for example, how many questions are there. Here, it is very explicit that they have divided, say for example, into two questions, right? I'll call it as A and B. You call it as 1 and 2, whatever it is the case, right? So, what are extra tropical cyclone will be the first part of my question. Discuss the weather effectivity induced by them will be the second part of the question. Somewhere I feel that the word, say for example, almost allocation between both this subsection can be somewhere equal. Okay. If at all, if it is 150 words, somewhere I can devote 75 and 75. If it is 250 words, I can do it somewhere around 125 and 125 words each, approximately. Right. Okay. Now, what is the approach? Approach is very simple. Somewhere I am going to define, or more than defining, right? I can also explain. I can define what exactly is extratropical cyclones. And it is also better that you explain this mechanism, right? Explain the mechanism. But though I use this word called as explain, somewhere I can talk about briefly, I can talk about the mechanism as such, right? So, for example, this will be your part A of the question demand. Then I have to talk about the explain the weather condition induced by this extratropical cyclone. Very simple, right? Along the cold front, what exactly will be the weather condition? Along the warm front, what exactly will be the weather condition? That's what somewhere you have to discuss. Right, my dear friends. Now, one by one. See here, uh, for example, see, when I talk about extratropical cyclone, some of you, right? Some of you, somewhere, if you're not reading this word extra, the entire question may go wrong. Okay. See, sometimes what happens, you know the concept, but you may not know the other name for it, right? Why I'm just telling you, for example, my dear friends, uh, I think last to last year, they asked about something called as primary rock, right? Very straightforward question. They asked about primary rock. And people are not aware of the primary rock, right? They do somewhere. I heard students saying that they do not know what exactly is primary rock. My difference, primary rock is the other name for igneous rock. Once you know that primary rock is the other name for igneous rock, then you will be knowing what is igneous rock. So most of the time, what happens? you know the question or you know the answer for the question, but you do not know that you know it. That's the only problem. Okay. Why I'm just insisting, I'll tell you, right? Sometimes, maybe in an examination hurry, you may read this question as tropical cyclones. It is not tropical cyclones, it is extra tropical cyclones. Cyclones that is somewhere confined beyond the tropical latitudes. Okay. So the extra tropical cyclones is very popularly called as temperate cyclones. You call them as what? Temperate cyclones. See, it is known by different names. You call them as a temperate cyclones. You call them as a wave cyclone. You call them as a frontal cyclone, right? It goes by different name. You call them as extra tropical cyclone, all one and the same, right? But the most commonest name is this temperate cyclone. Okay, right, my dear friends. Now, somewhere, though I have just written an answer, model answer here, but I would recommend that if at all, if you're starting your answer saying that extra tropical cyclones are popularly called as temperate cyclones, then examiner will be knowing that yes, you know the answer. Okay, right. So somewhere you can say it is popularly called as temperate cyclones. So after talking about temperate cyclones, approximately you can talk about the location where exactly you happen to have this, say for example, this temperate cyclones, right? Sometimes it is also called as mid-latitudinal cyclones. The system developing mid and high latitudes beyond the tropics are called as mid-latitudes or extratropical cyclones, or as I already said, it is very popularly called as what? Temperate cyclones. Okay. Generally, they say these are formed along a front in mid latitudes, right? Anywhere between 35 degree and 60 degree, both north as well as south, both the hemisphere. Okay, right. Rest all, we can take it, we can write it later. So somewhere we have to say where exactly this cyclone occurs. See, this approximately, my difference, when I use this word called as mid latitude, mid latitudes, actually speaking, the latitude where I have the flow of the westerly wind, right? Very theoretically speaking, that is what we call them as what? Mid latitude. But all for practical reasons, somewhere around the 60-degree latitude is the one. For all practical reason in climatology, popularly we refer it as what? Mid latitudes. Okay, right. So this cyclone is also called as what? Mid latitudinal cyclone. Now see, this is a latitude where I have a pressure system called as subpolar low. Right? You have a pressure system called as subpolar. You know that every 30 degree you have an alternate sequence of low pressure and high pressure. Okay, so this is a place where you have the somewhere occurrence of a low pressure, subpolar. Now what happened here? What happens here? Right? This is a low pressure. Low pressure is a zone of convergence, right? Now what happens, my dear friends, here? Two extremely contrasting air mass tries to converge with each other. Mid latitudes, exactly what happens, right? Somewhere two contrasting air mass. Say for example, maybe I'll use different color. Okay. Say for example, this is your 60-degree latitude. 60-degree latitude is a place where you have this subpolar low, right? A low pressure. So this is a place where I have two contrasting air mass which tries to converge with each other. One air mass which comes from 90-degree, say for example, latitude. This 90-degree latitude, I understand. Right? This is a place approximately where I have this polar high. Right? A wind which comes from polar region, you call them as polar wind. Right? This polar wind will be extremely cold. So I call it as cold polar winds. Okay. On the other hand, I have a wind which comes from 30-degree latitude. Right? 30-degree latitude, I have a pressure belt called a subtropical high. Obviously, a wind which comes from 30-degree latitude will be warm. So let me call this wind. I know the name of this wind. This wind very popularly we call them as what? Westerly. So let me call it as what? Warm westerly. Okay. Warm westerly. So what happens? When both these extremely contrasting air mass try to converge with each other, they do not readily mix with each other. They form a clear-cut boundary between them. This boundary is what? Very popularly you call them as what? Front. Right? You remember this particular cyclone is also called as what? Frontal cyclone. So the entire mechanism of tropical cyclone is all about this front getting divided and going for a circulation. Okay. So what is a front, if you ask me? As a layman, I would say It is all about the boundary of an air mass. Okay. So all this, say for example, whenever I talk about temperate cyclonic circulation process is very simple. If I know what is a front, you call them as a climatic front. Okay. It is all about the front getting divided and going for a circulation. So everywhere I'll be having this, right? Front as a word which is somewhere specified. Okay. As I said, right, front. What exactly is a front? I have just given you a hint. Okay. So what is this warm front? What is this cold front? I'll just tell you. Okay. Right, my dear friends. Now, as I already said, it's all about what is this temperate cyclonic circulation? It is all about the front getting divided and going for a circulation. See here what happens, my dear friends. What is the front? I have an idea. Okay. So somewhere what I'm seeing here is an aerial image of this front. Okay. Whatever I've just, right, what we have seen here is the aerial image. Okay. What you are seeing here is an aerial image. Okay. Right. A wind which is coming from 90-degree cold polar wind, which is trying to converge with this warm westerly. Okay. And the representation, see, for example, CP and MT air mass, type of air mass is also represented here. CP means continental polar. Continental polar means it is cold and dry. That is the meaning, right? They are cold, they are dry. MT means maritime tropical, right? Maritime means they are warm and wet. Warm and wet. Be it the temperature or be it the moisture content, both way they are extremely contrasting in nature. They don't readily mix with each other. Okay. So what happens? It forms a front. So after creating a front, see, front is more like a curtain, right? An air curtain, right? Somewhere few kilometers, somewhere if I'm just crossing this front, I can feel the difference, right? Contrasting difference between the air mass as such. So the entire cyclonic circulation, temperate cyclonic circulation is all about how this front getting divided and going for a circulation. Very carefully, if you look at it, see, assume this is just an answer writing practice, but still, if you have a confusion, right? Still, you have a confusion. Maybe sometimes uh, reading the concept through writing an answer is an indirect way of studying the concept. It's more like a reverse engineering. Okay, right? That's the reason. Somewhere I just don't want to tell you plainly. Okay, right, my friends. Here, what I'm just trying to say, what you find here, you find a creation of a stable front, right? Stable front. That's what the heading also I've just given it, right? Very popularly, the stage we call them as what? Frontogenesis, creation of a stable front. When I talk about stable front, I do not have a differentiation between cold front and warm front. So what is a front? As a layman, if I want to understand, I'll say front is more like boundary of an air mass. Boundary of an air mass. Of an air mass. Okay. So here, what I understand, I do not find any difference between cold front and warm front. What is the boundary of cold air mass is also the boundary of warm air mass. Very carefully, if you look at this diagram, right? Both red and blue, both you will be finding. Red, right? Say, for example, through the color red, it signifies that it is a warm front. Blue signifies it is cold front. So, first stage, there is no difference between this warm front and cold front. Then what happens? Somewhere, this cold front or this cold air mass will try to occupy the place of this warm air mass. So what happens? This cold front will start somewhere venturing into the regions of what? Warm air mass. As the cold air mass try entering, say for example, the warmer locations, this front will get divided as cold front and warm front. Stage 1, you do not have the difference between cold front and warm front. But stage 2, you have the difference. That's what we call them as what? Division of stable front. So once the front gets divided, this cold front alone will start, say for example, moving into the warmer regions. Because I understand, warm front do not have the ability to push what? The cold air mass. But cold front has the ability to push what? Warm air masses, just because of the density difference. So what happens? This cold front eventually goes for a circulation. The circulation of this cold front is what? Very popularly, we call them as what? Temperate cyclonic circulation. I've given you 6 stages. But what are the stages it is needed, right? Very important to represent in examination. Frontogenesis, very important. Creation of a stable front. Then division of a stable front. Front getting divided into two. This 3 and 4 is just namesake, right? I am simply saying quick shift of cold front. Somewhere I'm just telling you this cold front is what moving, right? Stage 4 is closing down of warm sector, right? Warm air mass, the ground connect becomes what? Very, very less. What is very, very important is stage number 5. You call them as what? Stage of occlusion. See, normally these two images, if I just take it, normally, say for example, students may complain that I do not find much difference between these two diagrammatic representation, right? If you want, I'll slightly zoom it. So students who are using mobile phones, maybe, right, slightly, you can start comparing it now. See, when I talk about these two images, closing down of warm sector versus occlusion, closing down of warm sector, cold air mass is slowly, steadily replacing the warm air mass. Now you may wonder, what is this? How it is replacing? Where all this warm air mass is going? Very simple. As and when the cold air mass starts pushing the warm air mass being less in density will start raising. And you know, whenever air mass rise will go for condensation, condensation will result in what? Precipitation. Right? That precipitation is what we call them as what? Temperate cyclonic precipitation. Okay, right. Here, what is the difference? Occlusion versus closing down of warm sector. Here, as I already said, cold air mass will start replacing the warm air mass. But stage of occlusion is the place where cold front will start replacing this warm front. Very carefully if I look at it. Somewhere this region I find that this cold front is now completely replaced, at least partially it has replaced this warm front. Right? When the front itself is being replaced, boundary itself is being replaced, you call them as what? Occlusion. When complete cold air mass or complete warm air mass, if it is removed from the surface, right? That stage is what we call them as what? Stage of dissipation. So here, the first part of the question, what is that you have to do if you ask me? The first part of the question, very simple. First, somewhere I have to define what exactly is temperate cyclone, or simply I can say, right, extratropical cyclones are also called as mid-latitudinal cyclones or temperate cyclones. Right? You also say the location. Generally, they are confined to mid-latitudes or somewhere around 60-degree latitude. Though I say 60-degree latitude, the circulation may happen till this 30-35 degree also. Okay. Then I can talk about the mechanism, right? How exactly it goes for a cyclonic circulation. See, if it is asked for 250 words, I can explain in detail, right? I can explain in detail. Otherwise, say for example, right, I can simply say that what are the different stages in this circulation as such. Okay, right. See, normally they say 6 stages. And one more thing, in examination, normally, right, what we do, you say that temperate cyclonic circulations is identified with the 6 stages. You may remember one, you may remember two, you may not remember three and four. Where I always suggest that do not say that how many stages are there. Simply you say the different stages involved in temperate cyclonic circulations are. Whatever you remember, you write it. What you should not forget is first two and last two. 3 and 4 is namesake because if you search in the net, few of the stages will be talking only about 5 stages, right? Few diagrams you'll be finding 6 stages. Okay, concept is important, number is not important. Okay, that is the first part of the question. Now coming to the second part of the question, discuss the weather effectivity induced by them. So what I can do, separately I can talk about the weather effectivity induced along the warm front, weather effectivity induced along the cold front. See, what is a stable front? I understand. Then somewhere stable front is getting divided into two, warm front and cold front. We have seen it, right? And what is actually moving, rotating is what? This cold front. Okay, warm front may not move, right? If you ask me, what will be the nature of this cold and warm front? Generally, my difference is cold front will be very, very steep. It will be very, very steep. Whereas warm front will be generally, right? Say for example, steep slopes. It will be having a steep slopes, whereas warm front will be having a gentle slopes. Gentle slopes. So why I am insisting on this fact, I'll tell you. When I say warm front has a steep slopes and, sorry, excuse me, cold front has a steep slopes and warm front has a gentle slope, because The slopes are very, very steep. It is not like a mountain. It is more like a, right, contrasting air mass. So what happens whenever this cold air mass starts, say for example, moving into the warmer locations, obviously I understand this warm air mass will start rising. Okay. If the steepness of the slope is very, very high, what happens? The rate of rise will be higher, right? The rate of rise is higher. Normally, right, I may find nimbus clouds here, nimbus clouds. Okay, not necessarily nimbus. I may find nimbus, I may find cumulus. Okay, if that is the case, this cold front is associated with heavy precipitation. This precipitation can either be rainfall or it can be snowfall. Okay, but along the warm front, right, I may not have that thick clouding that is happening or cloud formation that is happening. I'll be having precipitation, but this will be moderate to light showers. So what I have to understand, cold front is associated with intense weather phenomena, right? Or I can say intense precipitation, whereas warm front is associated with moderate precipitation. This is very, very important. Okay. Normally what happens, cold front is the one, sometimes cold front, right? Cold front is associated with the formation of what? A phenomena called a squall line. I've written it later, means, right? It is called a squall line. So, if you ask me what exactly is a squall line, right? Normally we say squall line is a region of bad weather effectivity. See, my dear friends, there's something like OOPS, object-oriented programming, right? Whenever I use this word called as bad weather, whatever you assume that it is components of the bad weather, I can always bring in, right? If you ask me, right, what are the components of the bad weather? I can talk about what? Heavy precipitation, very heavy precipitation, okay, including what? Cloud burst, right? Technically, there is a difference, I said, right? What is the only difference between heavy precipitation, normal precipitation, and cloud bursts? Is only the amount of precipitation, right? Then thunder, it is known for what? Thunderstorms, lightning, etc. Right? Lightning, etc. Then it may also known for what? Hailstorm, right? And others. So all intense weather mechanism, you take it, we call them as what? Bad weather mechanism, right? Squall line. Technical word is squall line. So normally squall line is generally formed very near to the cold front, right? Very near to the cold front. Okay, just slightly say for example, before this cold front, it will be moving. Okay. Now, why I'm using this word called a squall line? See, technically, even Wikipedia information says somewhere, right? A linear convective regions, right? Almost say, for example, almost convective zones, right? Or a quasi linear convective zone, which is associated with heavy precipitation, thunder, lightning, hailstorm, etc., is called a squall line. Why I'm bringing this squall line, I'll tell you, because this squall line is the one which sometimes gets transformed into tornadoes, right? The possibility of development of squall line, right? The squall line may sometimes gets developed into what? Tornado. Okay, tornado. See, temperate cyclonic circulation somewhere getting or the squall line getting developed itself is what? Rare. And somewhere the squall line resulting in tornado is again rare. Okay, so that's the reason we say tornado is a rarest of a rare phenomenon. Right? One small clarification, tornado, very technically speaking, right? Even say, for example, tornado, very popularly you call them as what? Twisters, right? Even Gulf of Mexico also, it is known for tornadoes. The clarification, tornadoes may occur in tropical region, that's okay. But tornado, when I talk about the mechanism, it is more like the temperate cyclonic circulation. Okay, right, my dear friends. Now, coming back to our question, just seeing whether we have answered the question. What are extratropical cyclones? Right? Somewhere we have defined it. Right? Maybe briefly, we also discussed about the circulation or mechanism as such. Weather effectivity, largely we have just divided into two. What will be the weather effectivity along the cold front? Simple, heavy precipitation or bad weather effectivity. What will be the effectivity, weather effectivity along the, say for example, warm front. Warm front, it is known for mild weather mechanism. Mild weather means very, say for example, less amount of precipitation, right? The wind speed may not be so high. Cold front, the wind speed can be slightly on a higher side. Okay. So when I talk about cold front, I am also talking about squall lines. I am also talking about tornadoes. That should be fine enough. Okay. Right. Right, my friends. Now coming to the second question. Again, what exactly we have taken, right? What we thought of almost discussing in yesterday's class. See, weathering is a complex phenomena involving a number of processes and is influenced by various factors. Okay, elaborate. First and foremost, if that is the case, I should know what exactly is weathering. Okay, examiner itself, he himself says or she himself says that weathering is a complex phenomenon. Complex phenomenon of what? Involving a number of processes, right? And is influenced by various factors. Okay. So somewhere I can talk about, say, for example, the number of processes through which weathering takes place, or say, for example, the different types of weathering also I can include along this process itself. And on the other hand, what are the various factors which influence the weathering, right? Right. For example, if I understand that weathering itself is what in situ breakage of rock, somewhere I should understand, right? What are the factors which influence the rate at which the weathering is taking place, right? Whether it is, say, for example, happening in a very, say, for example, almost in a fast forwarded fashion or in a very, say, for example, right? Maybe it takes its own time for this factors happening. That's what we have to discuss. Okay. Right, my dear friends. Now, if that is the case, how I can start this answer, if you ask me, very simple. First, let me define what exactly is weathering. Always, at least for geography questions, physical geography questions, any question that is asked, ask me which is the best way of starting the answer. If you ask me, I would say writing a definition would have been or will be the best way of, say, for example, answering the question. Okay. Right, my dear friends. Now, weathering is a complex phenomena involving a number of processes and influenced by various factors. As I said, this maybe in a line or two, you can say that what exactly is weathering, right? Weathering is defined as mechanical disintegration and chemical decomposition of rocks through the action of various elements of weather and climate. So the fundamental idea here, somewhere you're conveying the examiner that it is all about disintegration, or simply you can say, right? If these words are too technical, you can simply say it is in situ. This word in situ is very, very important. Okay. In situ means in its original location. If I have a mountain, the rocks are being separated from the mountain physically or chemically or biologically, whatever it is the case, right? This breakage of rock from the parent rock, breakage, right? Physical breakage or whatever it is the case, detaching, right? Is what we call them as what? Weathering. That's the reason we say in situ breakage of rock. It is in situ breakage of rock. We call them as what? Weathering. Okay. So somewhere I am defining what exactly is weathering. Now, what are the factors that controls, right? Controlling factors of weathering. See here, according to the question, writing the different types of weathering and right, explaining each and every type of weathering, that is not needed. Okay, right, right, my dear friends. Now, uh, controlling factors of weathering. The nature and magnitude of weathering differs from place to place. Yes, of course, we have an idea. For example, disintegration of rock is more effective in hot and dry region, coupled with those regions where frost action is more dominant, while chemical decomposition is more prevalent in hot and temperate humid conditions. Whatever it is the case, right? Wherever I have humid regions, their chemical, say for example, weathering is what? Very, very prominent. Okay. Apart from that, what are the other factors which determines the rate of breakage? Right? Composition and structure of rocks. For example, when I talk about, say, for example, William Morris Davis, who's regarded as father of geomorphology, he strongly believes that any landform is a result of, right, the function of structure, process, and stages, right? Now here, though that is not needed, structure of rocks plays a very, very important role. in determining the rate of weathering, the rate at which the rocks are subjected to what? Breakage. Okay, in that way, when I talk about the composition and structure of rocks, at least I know that there are three types of rock: igneous, metamorphic, and sedimentary rocks. Sedimentary rocks, right? Now, see, this igneous and metamorphic are more resistive to breakage, right? Very easily they will not break. Whereas sedimentary rocks very easily, say for example, it breaks. I mean, weathering is somewhere fast forwarded in sedimentary rocks because sediments which is collected eventually becomes a rock. You call them as what? Sedimentary rocks. So maybe say for example, they are not so tightly packed, or say for example, they are not so strong as igneous or metamorphic rock. Sedimentary rock can also become metamorphic rock. But igneous and metamorphic rock are more resistive to erosion, more resistive to weathering. See, where I can see this practical example, Himalayas. Himalayas landslide is very, very common. One repeated a very famous question, famous in the sense popular question. Last 9 years, three times, thrice they have asked this question. It means every third year they ask this question. Because every year the demand of the question comes in, right? Why Himalayas are more prone to landslide than that of Western Ghats? Western Ghats and Himalayas are only two regions in India which is prone to landslide to the degree of disaster. Only two regions: Himalayan region and the western side of Western Ghats. Not even entire Western Ghats, only the western side. One of the reasons is that Himalayas, they are made up of sedimentary rocks. One of the reasons. There are n number of reasons. But one of the reasons, sedimentary rocks, very easily erodable, very easily breakable, weatherable. Okay, structure of rock plays a very important role. Then number two, nature of ground slopes. What happens? The slope is very steep. Weathered material will be removed. There will be mass wasting, right? Or I can call it as what? Landslide. Right? If weathered material is removed, again the fresh slope is getting exposed. Again further weathering, again landslide. Right? On the other hand, if the slopes are very gentle, the weathered material will be remaining there itself, right? It may not, say for example, will be resulting in landslide. Very rarely it will be resulting in what? Landslide. So, nature of slopes also plays a very important role. Climatic variations, right? See here also somewhere we said, if it is very humid, humid regions, somewhere chemical decomposition is very, right? Very, very common. For example, if I just talk about karst topography, right? Even when I talk about hydration, oxidation, right? Forming solutions, etc. Chemical decompositions. Okay. Wherever humid conditions are there, right? Normally, say for example, the chemical type of or chemical weathering is what? Very, very common. Okay. Even wherever you have the maximum diurnal variation, diurnal variation, wherever you have annual range of temperature, right? More range of temperature. And talk about annual range of temperature, right? If both are more, diurnal means range of temperature in a single day, annual range of temperature means range of temperature in one given year. If both are high, physical weathering will be very, very right, prominent. Even frost action, salt action, right? All this chemical variation, floral effect, biological weathering. Am I right? Somewhere the roots of the trees, plants will penetrate, right? That will also result in what? The breakage of the rock. Floral, right? Floral effects, right? Flora, effect of flora, right? So very, very important. Somewhere if you can explain it, better you can explain it. Okay. Right, my dear friends. Now somewhere, I'm justifying the fact that, right, what are the factors somewhere which has influenced the weather, right? And when I talk about the number of process, maybe here, when I talk about the first part of the question, maybe I can somewhere talk about the types of weathering as such in a nutshell, right? And talk about physical weathering, maybe in a sentence or two, I can say what exactly physical weathering. Block disintegration due to temperature or due to frost action, or the physical changes in the rock strata, you call them as what? Physical weathering. A few examples if you can give, more than enough, right? Right. Prominent weathering agents includes moisture, water, frost, insolation, and wind. Chemical weathering includes oxidation, carbonation, hydration, solutions, etc. Okay. So weathering agents include oxygen. Obviously, say for example, when I talk about oxidation, it is oxygen, right? Carbonation is carbon dioxide. Hydration, of course, somewhere presence of hydrogen is needed. Okay. I can also talk about biological weathering, where plant weathering, animal weathering, biochemical weathering, anthropogenic weathering. Nowadays, say for example, is one fact or one very important or alarming level of impact we have on the nature is anthropogenic weathering. See, for example, normally nature will take millions of years to denude a mountain. Aravali, the age of Aravali is somewhere around, it belongs to Paleozoic era. The age of Aravali mountain is believed to be somewhere around, right, 600 million years ago to 225 million years ago. 225 million years ago, right? When I said 225 million, approximately I can say it is 20 crore or 20 crore years old, approximately. Right? What nature was not able to reduce for the past 225 million years, still somewhere the remnants is there, right? Human has a capacity of removing the same in what, 20 years. Okay. Whatever it is the case, it is the negative impact of human being on the nature. Okay, whatever it is the case, right? Anthropogenic weathering. Man-made weathering, popularly we call them as what? Anthropogenic weathering. Okay, right. The various weathering agent involves vegetation, animals, right? Even microorganisms, right? That is nothing but what? Flora and fauna. Okay, right, my dear friends. So two questions. In a nutshell, what exactly we have to discuss about, right? We have taken it. Now, one more question. Analyze the locational aspect and formation of oceanic features in the light of plate tectonic theory. See, first and foremost, let's understand the demand of the question. What is the demand of the question? They are asking locational aspect, right? And the formation of what? Oceanic features in the light of plate tectonic theory. Okay, in the light of plate tectonic theory. So, somewhere in a nutshell, I can talk about plate tectonic theory. What is plate tectonic theory? What is the objective of plate tectonic theory? What exactly plate tectonic theory tries to explain? Okay. What is the principle based on which this theory was formulated? Okay. Right. What are the preconditions taken for or considered for the validity of the theory? Something like that. If I'm not getting into the details, in a nutshell, I can talk about these facts. Then, plate tectonic theory, say for example, they talk about or they analyze the plate boundaries in detail. If that is the case, somewhere I have to talk about the different plate boundaries, but very, very important. We are talking about what? Oceanic features. It means we have to talk about the plate boundaries of the ocean. And in that plate boundary, location, and talk about location, somewhere we have to talk about the plate boundaries of the ocean. Wherever I have the plate boundaries in the ocean. Then in that plate boundary, which is there in the ocean, what features will be having? Right? How exactly they'll be formed. That's what somewhere I have to integrate it. Somewhere try to revolve around these keywords. Location, right? Location in the sense, not necessarily I have to give a physical example. Even if you're giving a physical example, exact location, right? Nothing wrong in it. But in general, and talk about location, we mean to say that whether it is a convergent boundary, divergent boundary, or transform boundary, right? Approximate location in the world map also as an example also you can give. Formation, right? Formation. This location, what exactly is the formation? Formation of what? Formation of oceanic features. So see, nothing wrong. If I talk about the formation of the landform feature, nothing wrong, but it is a junk. Junk means that particular point or a sentence or a paragraph may not fetch you mark. That's what we call them as what? Junk. So somewhere in general studies or any examination or any paper you take it, try to avoid this junk. General studies particularly, you do not have time, you do not have word, you do not have space to accommodate junk. Only what is relevant to the question, you write it. Right? Right, my dear friends. Now, first when I talk about plate tectonic theory, somewhere Very briefly, I can talk about plate tectonic theory. Okay. So somewhere I can say plate tectonic theory is based on the principle that lithosphere floats over asthenosphere and it eventually drifts under the influence of convective magma currents. See, the uppermost layer of this earth, we call them as what? Lithosphere. So plate tectonic theory strongly believes, or it is based on the principle that this lithosphere, right? Lithosphere floats over asthenosphere, right? Floats over asthenosphere and it horizontally moves over what? Asthenosphere. Why it is moving? Very important. Maybe here I have not included that word, right? It is moving under the influence of convective magma currents. Convective magma currents. Okay. And one more thing, let me tell you, there are a few keywords which will convey the examiner that you know the concept. That way, when talk about entire plate tectonic theory principle, right? Based on what, say for example, belief it was constructed, if you ask me, it was constructed on a belief that why exactly, what is the causative factor for the movement of the plate? Alfred Wegener has given so many, right? Say for example, hypothesis, pre-assumptions, suggesting that why exactly the continents are moving in a particular direction and others. But plate tectonic theory has given one thing which is not easily verifiable. You call them as what? Convective magma currents. A kind of a movement of magma within a asthenosphere is what we call them as what? Convective magma current. Okay. Now see, diagrams for this convective magma current is not needed, right? But still, if you ask me what exactly is this convective magma current, see, avoid diagrams, right? Complex diagrams, you may avoid it. If you have a ability of representing or presenting a complex diagram in a simple fashion, right? It is good, right? Now see, you find a movement, right? You find a movement of magma within asthenosphere. Very carefully, this diagram itself shows you what exactly is this plate tectonic theory. What is a plate? First and foremost, if you ask me what exactly is a plate, I know what is lithosphere. The fragmented lithosphere, fragmented, right? This fragmented lithosphere is what we call them as what? Plate. Lithosphere is a very thin unit, right? Very thin layer, very thin, solid rock layer. And somewhere I understand, say for example, it is actually floating over a layer of magma. And somewhere, since there is a movement within asthenosphere, this lithosphere fails to exist as one single unit. It breaks into fragments and pieces. That fragmented pieces of lithosphere is what you call them as what? Plate. Okay. Now here my difference. When I talk about plate, now see, when I talk about convective magma current, you find this mantle. Sometimes you call them as what? Mantle convection. Right? Movement. Right? Whenever this magma is moving, it is strongly believed that along with the magma movement, lithosphere also moves. Okay. Wherever magma subsides, convective magma or this magma subsides, there I'll be having subduction taking place. Wherever the magma is rising, right, there I'll be having this mid-oceanic ridge or this oceanic divergence takes place. Okay, right. Now, and one more thing, whichever feature, if I just talk about the features, oceanic features, okay, when I talk about oceanic features, somewhere I have to say, if it is subduction zone, because I'm just analyzing in the light of plate tectonic theory, somewhere I should more believe, say for example, normally the theory says whenever this oceanic crust and continental crust converge with each other, oceanic crust being heavy intensity will go for subduction. But plate tectonic theory slightly see them in a different perspective. What is that perspective? Subduction is taking place because this magma is going for what? Subduction, right? Somewhere that's how we have to analyze it here. Okay. Now, what is a plate tectonic theory? Somewhere in a nutshell, I have just given you. Right. If you want to add, for example, assume that this is a 250 words question. Then you can say the entire lithosphere is divided into several plates. Right? Don't even write how many plates are there. Right? To be very precise, they are divided into 7 major plates. Right? Right? 7 major. The lithosphere is divided into 7 major plates. and several minor plates. To be very precise, it is approximately somewhere around 20 minor plates. If you want to give the name, you give it. Pacific plate, North American plate, South American plate, Eurasian plate, African plate, Indo-Australian plate, and Antarctic plate. These are the 7 plates. Okay, right. Now, talking about this plate tectonic theory in a nutshell, right? Nutshell, you can also say plate tectonic theory helps us in understanding the locational aspect of endogenic process and endogenic features. Okay, so having said that, all endogenic process and features are confined to plate boundary. So directly, I can start talking about the different types of plate boundary. So according to plate tectonic theory, there are 3 types of plate boundary. What are the 3 types of plate boundaries? You call them as what? Convergent, divergent, and transform boundary. Name itself is self-explanatory. Maybe this is 3-dimensional. Examination, if you want to put it simple, you can go for what? 2-dimensional representation. Convergent boundary means somewhere I can take 2 blocks and say that they are moving towards each other. Divergent boundary means same 2 blocks, I can say that they are moving away from each other, something like that. Okay. Transform boundary is more like slide past each other. Okay. Slide past each other. Neither convergent nor divergent, you call them as what? Transform boundary. Divergent boundary, very popularly you call them as what? Constructive boundary, because new rocks will be formed. Convergent boundary is called as destructive boundary because old rocks will be destructed. Transform boundary, you call them as what? Conservative boundaries. Neither constructive nor destructive. Neither new rocks are formed nor the old rocks are destructed. You call them as what? Constructive boundary. Neither it creates nor it gets destroyed. Okay, right. Now here, 3 types of boundaries we have taken. But here, as I already told you, we are going to talk only about the boundaries which is there in the ocean. In that way, if I just talk about the convergent boundary, to be very, very practical, my dear friends, if you ask me what are the different types of convergent boundary, because we have 2 types of crust, because we have 2 types of lithosphere, this convergent boundary itself, somewhere we can divide them into what? 3 types of convergence. See, for example, if I have crust, see, crust and lithosphere, technically speaking, slightly there is a difference. But somewhere if you ask me, what are the 2 types of crust? Obviously, everybody knows that there are 2 types of crust. One I call them as what? Oceanic crust, right? You call them as what? Oceanic crust. And 2, you call them as what? Continental crust. Continental crust. Oceanic crust is largely made up of sima. Continental crust is largely made up of what? Sia. Oceanic crust is basaltic. Continental crust is granitic. Oceanic crust are heavy in density, somewhere around 2.9 or 3.0 grams per centimeter cube. Okay. Continental crust, somewhere they are light in density. Numbers are not so important, 2.7 grams per centimeter cube. Okay. But one thing I want to tell you that oceanic crust is heavier and continental crust is lighter. Okay, 2 types of crust is there. Now, when I talk about the convergence, I understand convergence is the place where 2 crust or 2 lithosphere will converge with each other. If that is the case, how many different types of convergence, right, we'll be having? Right? What are the different types of convergence we'll be having if you ask me, right? I'll be having 3 combinations of convergence. So what are the 3 different combination of convergence I'll be having? Let me tell you. One, I call them as what? Ocean continent convergence. Number 2, I call them as what? Maybe I'll prefer a different order. Okay. Both side I'll be having continental crust. Continent convergence. 2 is ocean convergence. 3 is ocean continent convergence. Now this particular question is talking about, say for example, the locational aspect, right, of these things in oceanic regions or oceanic features. Now, where exactly oceanic features will be developed, if you ask me, Oceanic features will be getting formed either along ocean convergence, or say for example it happens along ocean continent convergence. It means any convergent boundary where at least one crust should be what? Oceanic crust. Okay, oceanic crust. That's what we have to somewhere talk about. Okay, so what are the features? When I talk about, say, for example, ocean continent convergence, right? As I said, the answer is more like somewhere I can treat it as more like object oriented programming, right? If you ask me, okay, give me one classical example of this ocean continent convergence, it is nothing but what? Pacific Ring of Fire. Pacific Ring of Fire. So, when even I think the last class, yesterday's class, I think we discussed about this Pacific Ring of Fire. Okay, so I can take Pacific Ring of Fire. In that Pacific Ring of Fire, whatever is confined to the oceanic region, I can write it. What all I can write it, right? This is the place where largely oceanic crust and continental crust goes for a convergence, right? Number one, I'll be having what? Trench formation. Subduction will take place, right? Subduction. Subduction is a process, right? The visible zone of subduction, we call them as what? Trench. I can give some of the examples of a trench, right? For example, entire Pacific Ocean is known for what? Trenches. So many trenches out there, right? Along this South American coastline, where I have this Nazca plate and South America plate converge with each other, that's a place where I have the longest trench of the world. You call them as what? Chile Peru Trench. Okay, here I have not given the map. Okay, no problem, right? Chile Peru Trench. Somewhere, say for example, along the American coastline, North American coastline, I have this Guatemala Trench. I have Aleutian Trench. Along the Asian side, I have Kuril Trench. I have Japan Trench. I have Izu Bonan Trench. I have Ryukyu Trench. I have Philippines Trench. We have the world's deepest trench called as Marianas Trench. So Marianas Trench, what type of boundary we have this Marianas Trench, if you ask me? Marianas Trench, the world's deepest trench, Marianas Trench, is actually identified along ocean-ocean convergence. The convergence of Philippine plate and Pacific plate. Philippine plate is also oceanic crust. Pacific plate is also oceanic crust. Both convergence results in what? Marianas Trench. Slightly the southeastern side of Japan. Okay, so that's what somewhere, right? In general, I have talked about what are the different features we have. The movement of the plate results in building up of stresses. Okay, just explaining it, which leads to folding, faulting, and volcanic activity. The major plates are surrounded by fold mountains, ridges, trenches, and faults, right? But what we have to concentrate more is what? Ridges, trenches, and volcanoes. Okay, right. Now here, somewhere deep oceanic trench. How exactly these deep oceanic trenches are formed? Somewhere we can talk about it. The concept of ocean-ocean convergence helps us in understanding the formation of, okay, what all if you ask me, right? Number one, as I already said, we'll be having trench. Denser oceanic plate subducts below the less dense, it's not oceanic plate, it should be continental plate. Okay, continental plate. Continental plate forming a trench along a bound, already we said. And not only that, this trench, right? When talk about, say, for example, this trench, my dear friend, somewhere it goes for a destruction. Subduction will lead to destruction. Maybe this diagram will give a larger picture. Right. See here, wherever this oceanic crust and continental crust goes for a convergence, it results in subduction. Subduction results in destruction. What is destruction? Melting of rocks, you call them as destruction. Only oceanic crust goes for destruction. So when the pressure builds, it rises and forms what? Volcano, right? It forms volcanic arc. Okay. And not only that, even if it is going to happen in the middle of the ocean, where oceanic crust and oceanic crust is going for a convergence, here also destruction happens. Here also volcanoes will happen, right? So you'll be having volcanoes, right? And these volcanoes, not only, and see, right? All these volcanoes generally, right? They find this island arc. Island arc. Okay. So what are the features? Somewhere let me tell you. Number one, I can talk about the trench. Trench. Number two, subduction leading to destruction. destruction resulting in the formation of volcano. And of course, when I talk about, say, for example, just the rise of magma, if the magma itself is coming out, you call them as volcano. No? If somewhere, if it is rising the part of the crust, the movement of magma, if it is rising the part of the crust, I call them as what? Island arc. So what are the different features you have? Number one, right? You'll be having trenches, you'll be having volcanoes, you'll be having islands. Okay, these are the oceanic features what you have along the convergent boundary. Okay, right. Only examples I have to give. Trench, as I already have given you a trench. Volcano. Indian example itself I can give. Andaman and Nicobar Island is a classical example where convergence of two plates resulted in islands. What are the two plates? Eurasian plate and Indo-Australian plate. Andaman, right? Plate bound. Even Indonesia, the same two plates. It has given the island arc. Within the island arc, I do have volcano, and this volcano is also what? Somewhere I understand it is a volcanic island. Okay, I have barren islands, I have Narkundam islands. I can give that example. Okay, right, my dear friend. So along the convergent boundary, what is the feature? We have an idea. Now, when I talk about the divergent boundary, my dear friends, divergent boundary. Here, directly I'll just come here. Divergent boundary. Here, what are I can write it. Now, somewhere I am writing this or explaining in the light of plate tectonic theory. If that is the case, of course, I can say, right, it is diverging. But why it is diverging? According to plate tectonic theory, wherever there is a magma rise, wherever there is a rising convection of magma or mantle, it results in what? Divergence of the plates, right? There, almost it opens the lithosphere. The oceanic crust almost opens up. The magma comes out and forms a mountain-like structure. This mountain-like structure, we call them as what? Mid-oceanic ridge. Kind of a, right? Ridge is more like a mountain. Okay, you call them as a ridge. Why you call them as mid-oceanic ridge? Because most of the time it will be there in the middle of the ocean. Okay, so here I understand. The most commonest feature, when I talk about the divergent boundary, somewhere. Finest example is mid-Atlantic ridge. Entire Atlantic Ocean itself is formed out of this rifting divergence. Okay, you'll be having this mid-oceanic ridge. Give one classical example, mid-Atlantic ridge, formed between North American plate and Eurasian plate divergence, South American plate and African plate divergence. If you want to give a specific examples also, you can give it. What is the specific example? The divergent boundary in the northern hemisphere, we call them as what? Dolphin ridge. Sorry. The mid-Atlantic ridge in the northern boundary or northern hemisphere, you call them as what? Dolphin ridge. And southern hemisphere, we call them as what? Challenger's ridge. Okay. Right. Number one. Right. We have this ridge. And not only this ridge. When this ridge emerges above mean sea level, I'll be having islands. If this island is large enough, there I can also have what? Volcano. Okay, volcano. So somewhere if I just sum it up, my friends, what are the oceanic features I'll be having along this convergent and divergent boundary, right? Convergent and divergent boundary, if you ask me. Okay. See, here I am talking only about oceanic convergence and oceanic divergence, right? Convergence, I'll be having the formation of trench. Divergent, I'll be having the formation of ridge. Okay. Both the places I'll be having islands. I'll be having islands, right? Island arc I'll be having. Here also I'll be having island. Okay. And sometimes these islands are also referred as hotspot island. Hotspot itself is a separate concept, right? We may see it in some other, say for example, discussion, right? You call them as hotspot islands. Okay. Here also you do have volcano. Here also you have volcano. But one small difference is there. This volcano, what I have along the convergent boundary, generally they belong to intense type. They belong to intense type. Generally, you call this as Vesuvian, or it can be an example of Pelian. right? They are explosive type of volcanoes. They are explosive type. But the volcano, what you have along the divergent boundary, they actually belong to quite a type. They belong to a type of volcano called as Hawaiian type of volcano. Hawaiian type. Okay. So this is the basic difference. What are the features? Right. The oceanic features I'll be having along convergent and divergent. These are the features. Transform boundary of the oceans can also be regarded as a divergent. Something, whatever you have it along the divergent boundary, right? The similar features you may have it along what? Transform boundary. Okay. And one more thing, my dear friends, along with the ridge, you can also talk about a fracture zone, right? Fracture zone, right? Sometimes you would have heard about Romanche deep. Sometimes this fracture zone is regarded as a deep trench, right? Trench is different, fracture zone is different. Okay, so these are some of the features. I have to give an example. Right, that's it. Okay, so right, my friends. Now, somewhere I think we have answered this question. Analyze the locational aspect and formation of oceanic features in the light of plate tectonic theory. We have answered it. Okay, maybe I have just given you the consolidation also. Okay, right. Now moving on further. Right. I feel that this question, maybe even yeah, last year also they asked about current, but this year asking about current relevance of, say for example, this year somewhere I feel right asking about current, specific current, El Nino, right? Because this is a year of El Nino. Okay, right, my friends. Now, okay, discuss the impact of ocean currents on global and regional climate. See, this question is very straightforward, direct. They're not asking you to explain what exactly is a current. What are the different currents, right? Explaining the mechanism of the current, that and all they are not asking. Okay. Somewhere they are simply saying that discuss the impact of ocean currents on global and regional climate. But still, I would recommend somewhere you have to tell the examiner that I know about ocean currents. But somewhere, see, very briefly, right? Let's not explain. Even I have used this word called as explain. Don't even explain. Okay. Even don't talk about originate also. Simply you talk about the different ocean currents. What exactly is a current? See, what is a current? Normally we say anything that flows continuously, you call them as what? Current. Right? Anything which flows continuously, you call them as current. Flow of electrons continuous, you call them as current. Even air mass, if it starts flowing continuously, you call them as what? Air current. So that's the reason we say anything which flows continuously, you call them as what? Current. So any large scale continuous movement of water in a particular direction and for a sustained period, you call them as what? Ocean current. The large scale continuous movement of ocean water in a sustained direction and for an extended period, you call them as what? Ocean currents. Okay. Now, after suggesting that ocean current, somewhere I can say that largely, largely there are two types of currents. What are the two types of currents? Because directly I'm going to start answering the questions, right? So based on temperature, you call this current as cold current and warm current. See, of course, I understand. There is no temperature defines what exactly is a cold current and warm current. There is no temperature that defines, as I said, right, what is this cold and warm current. But normally we say colder than the adjoining water, you call them as cold current. Warmer than the adjoining water, you call them as what? Warm currents. Okay. This cold current always comes from higher latitude. Always. And warm current always comes from lower latitude. Relatively lower latitude. Okay. Now here, before starting talking about, say, for example, the specific currents, First, I have to somewhere say that what exactly is the effectivity of a cold current and warm current. Two things, right? When talk about, say, for example, directly I'm just talking about cold and warm current. Okay, I'm going to talk about cold current. I'm going to talk about warm current. So somewhere I should say cold current. Number one, it will reduce the temperature. That is okay. If it is reducing the temperature, obviously speaking, adjoining coast, right? See, one more thing. Climate is a concept which is applicable only in the land. But ocean's influence can be felt in the land. But climate, I'll be having only in the land. Maritime influence can be there. Influence of the air mass can be there. Okay. If that is the case, I am going to talk about the cold boundary current, the current which runs along the coastline. It will reduce the temperature. It will induce cold condition. Okay, it will induce cold condition. But what is very interesting, cold condition somewhere will be resulting in creation of what? High pressure. And my dear friends, high pressure is known for what? Inducing dry condition. Okay, dry condition, right? So what is very, very important? Cold current, wherever I have a cold current, okay, it reduces the temperature, cold condition, that and all it is okay. Cold current is generally known for inducing dry condition. Okay, this is very, very important. This concept is very, very important. Whereas, if I take the same analogy, warm currents, okay, say for example, they are known for inducing wet condition. Wet condition. This is the fundamental idea. Whenever whoever asks for the influence of ocean current on any climate, first and foremost, what I should talk about is the right. What exactly is the condition that this current is going to result in the adjoining coast? Again, I repeat. Warm current is associated with inducing wet condition. Cold current is associated with inducing what? Dry condition. Okay. And one more thing. Normally, I'm just showing you these currents. Right. I've just given you some of the currents where I'll be discussing about it. Okay. But let me tell you, see, for example, current, one thing. We are bothered only about the currents which runs along the coastline, because only this current which runs along the coastline can influence the temperature, humidity, right? Temperature and humidity of that particular place. And all these currents, my dear friends, all these currents, if you take a very close look, you'll be finding one similarity. What is that similarity? They take the name of the coastline itself. Okay. For example, you call them as California current because it is running along the coast of California. You call them as a Gulf Stream because it runs along Gulf of Mexico. You call it as Peru current. Sometimes you also call them as what? Humboldt current because it runs along the coastline of Peru. You call them as Brazilian current because it runs along Brazil. You call them as what? Canary current because I have an island here, very near to Africa, but politically belongs to Spain. This island you call them as what? Canary Island, right? Accordingly, you call them as what? Canary current. Again, I have a place called as Benguela, right? Western side of Australia, West Australian current. Eastern side of Australia, I have this East Australian current. So, don't take some specific efforts in remembering the currents, name of the currents as such, because somewhere currents are named after the coastline itself. Now, see, barring some exception, largely if you are there in the tropical regions, if you're there in tropical and subtropical region, almost say for example, see, tropical and subtropical region, almost all the currents are over. Okay. If you're there in tropical and subtropical region, somewhere till 45 degree, I'll take it. Right? Tropical and subtropical region. Till here, I'll take it. Okay. What I understand, where the maximum section or the near complete current of the world is over. Only marginal exceptions I have. Now, why I have taken this tropical and subtropical region, I'll tell you, because if you're there in tropical and subtropical region, any ocean you take it, any ocean, right? I'm just marking the midpoints, right, of any oceans. Any ocean you take it, you find a similarity. What is that similarity? I'll tell you, right? For example, with the reference point, I call them as what? East versus west, right? What I understand here, my friends, with the reference point, what I have just taken, if you're there along the western side of the ocean, I'll be finding warm currents. And if you're there in the eastern side of the ocean, I'll be finding what? Cold current, right? This understanding is very, very important, right? That's the reason normally we say west boundary current. See, this point is with respect to the ocean. It is with respect to the ocean as such. So with respect to the ocean, west is warm. Western section of the ocean is warm. But only confusion. See, I should not call it as a confusion. I should call it more like a clarification. What is western side of the ocean becomes eastern side of the land. Okay. So if I'm just taking any land as a reference point, right? Exactly it changes. Eastern side of any land will come under the influence of warm current. Western side of any land will come under the influence of what? Cold current. Okay. Now, why I am insisting is very simple, because why I am just taking this point, particularly, when say, for example, the very next question, I have just taken that question for our discussion. If I'm there in the land, right, particularly if I'm there in the tropical region, I know the fact that western side of the continent comes under the influence of what? Cold current. Cold current is known for what? Inducing dry condition, right? And that's the reason, my dear friends, western side of the continent, all the western side of the continents you take it, this is the place where I'll be finding what? The deserts, tropical deserts of the world. Okay, that's what the fact, what I just want to give you. So largely, western side of the ocean comes under the influence of warm current. What is west of ocean becomes what? East of land. Okay. Now I can talk about the weather effectivity induced by it. Okay. Now see, for example, I talk about the global and regional climate. So normally when I say global climate, no need to individually specify it. For example, I can say that wherever I have warm currents somewhere, you'll be having wet condition. Wherever the region comes under the influence of cold current, I have dry conditions. So somewhere I can talk about the locational aspect of deserts, right? And talk about deserts particularly, right? Cold current, particularly when I talk about cold currents are associated with what? Desert formations of the world. Okay. Number one, this is global. Okay. And when I say warm currents associated with wet condition, again it is global. Now I have to go for regional, right? Specific, for example, right? Specific one. Now, what are the different ones I can take it? For example, I can talk about Norwegian current, only the specific. I have given you plenty of examples. Norwegian current. Now, Norwegian current is very, very important. If you ask me why, because among all the currents, right, or to be very precise, among all the warm currents, if I just take it, that current which reaches the highest possible latitude is what? Norwegian current. It reaches Norwegian Sea. No other warm currents reaches that much high latitude. What is the significance of Norwegian current? Norwegian current is a warm current. This is the current which keeps or which makes Western Europe warm. Western Europe comes under the influence of what? Warm current. Norwegian current. That's the reason. Among the temperate regions, right? Western section of this continent is what? Warm. Otherwise, any other place you take it, western section of the continent will be cold. But this is warmer. It will be warmer than the eastern section. See how warm, if you ask me, this Norwegian current, right, is responsible for making this Western Europe warm. Number one. Number two, it also does not allow this Norwegian Sea to even freeze, right? To freeze even during what? Winters. It gives you a port accessibility. But for climate, no need to talk about it. Somewhere I can talk about how exactly the western section of the continent in temperate regions are kept what? Warm. Right? Similarly, when I talk about Canada, also temperate region, you take it. Again, it comes under the influence of what? Warm current called as what? Alaskan current. Okay? Right. Now, this is number one. Okay. Apart from that, specifically, I can talk about the desert formation. The influence of the Californian current is the one which has formed the Sonoran Desert. Peruvian current has resulted in the formation of Atacama Desert. Benguela current has resulted in the formation of Namib and Kalahari Desert. Canary current is instrumental in forming almost the drier Saharan Desert. Western Australian current is known for somewhere the development of what? The Great Sandy Desert, Victorian Desert, and right, the Gibson Desert. Right. Apart from that, right, somewhere specifically I'm just talking about what exactly is the influence of this current as such. Okay, right. Even I can talk about, say, for example, the cold current, Oyashio current, Labrador current, how exactly they are keeping the eastern side of the temperate regions cold. Okay, right. Now, what is very, very important, if at all, if the word limits talks about, definitely speaking, I should talk about El Nino, right? I should talk about La Nina, right? I should talk about Indian Ocean dipole positive and negative phases. For example, what is El Nino if you ask me? What is El Nino? See, for example, Pacific Ocean you take it. I think already we have discussed, right? Earlier I have just discussed about this El Nino. See, Pacific Ocean, normally the Peruvian coast comes under the influence of a cold current and eastern side of Australia comes under the influence of what? Warm current. Okay. Now, whenever this condition completely reverses, if Australia comes under the influence of relatively cold water, whereas if Peruvian current comes under the influence of warm water, that is the condition of what? El Nino. Completely it changes. So normally what happens? The Peruvian coast, which will be dry largely during El Nino conditions. See, El Nino conditions, Peru coast will become what? Warm. If Peru is becoming warm, I understand Peru will also become what? Wet. Correct? Because warm currents are associated with what? Wet condition. Atacama Desert, which is regarded as one of the driest tropical desert during El Nino condition, becomes one of the wet locations of the world. Right? So El Nino is associated with interchanging of this currents. If not the currents, at least the temperature of the ocean goes for what? Interchanging. Right? The cold Peruvian current is replaced by warm waters. That condition you call them as what? El Nino. Reversal of the normal, you call them as what? La Nina. Similarly, whatever is El Nino and La Nina, if it is happening in Indian Ocean, right, somewhere, right, the western section of the Indian Ocean, if it is becoming warmer, that is what you call them as what? Indian Ocean dipole negative phase. The normal condition of Indian Ocean, you call them as what? Indian Ocean dipole positive phase. IOD positive phase, right, and La Nina, they are favorable condition for monsoon. Whereas IOD negative phase and El Nino, right, they are unfavorable condition for southwest monsoon. See, this year, it's quite surprising, of course. They'll be coming up with the right mechanism which explains that why exactly we have this intense precipitation that is happening. Because now what is we are having simultaneously is El Nino and monsoon also we are having surplus. Okay, right, my dear friends. Now, largely I have just told you specific examples of Norwegian current we talked about, and general examples of all these cold currents and warm currents we talked about. And we also have taken the case of El Nino and La Nina along with Indian Ocean dipole positive and negative phase. That should be more than enough. Okay, right. Right, my dear friends. Now coming to one more question. Right, one more question. Practically speaking, so given the time, this may be the last question of the day. Okay, it says, okay, see, the question says, almost all, a very beautifully drafted question, though I, okay, almost all, it is not all, almost all tropical deserts are located in the western coast of the continent. Somewhere the previous question discussion has given you a hint about this question, right? And one more thing, my dear friends, whatever I have read till now is not a question, it is a statement, right? Almost all tropical deserts are located in the western coast of the continents, right? Located in the western coast of the continent. Now, what they are asking, what are the different factors that results in the desert formation, right? This is factor number one. Factor number one. See, in a way, while answering, when we are answering this question number one or the first part of the question, right? Of course, we are going to justify that why exactly it is formed along the western coast of the continent. Separately, I should not focus on that, right? While answering this itself, I should talk about why exactly it is located along the west coast of the continent. Okay. And the second part of the question, I have to explain that. Also explain the reason of Thar being a desert. This is the second question because Later we'll understand. Okay, of course we know. The rest of the deserts, what we have taken, tropical desert, right? Sonoran Desert, Mojave Desert, Atacama Desert, Sahara, Kalahari, Namib, the Australian deserts, right? Gibson, Sandy, all these deserts. Somewhere I understand they are located along the coastline. Somewhere the influence of the cold ocean currents plays a very important role. Offshore trade winds plays a very important role. But Thar Desert is not on the coastline. See, it is there on the western side of the right western side of our country. That's okay, but it is not on the western side of the continent as such. Because what lies in the western side of Thar Desert is some fertile plains of Pakistan, right? So somewhere, why Thar has become a desert is somewhere different from the rest of the desert formation. Okay, maybe first and foremost, let me define what exactly is a desert. Okay, so in that way, if you ask me what exactly is a desert, if you ask me any place which receives less than 30 centimeters of annual precipitation annually, and which is not dependable, is qualified to be called as a desert. See, dependable in the sense, see, some of the deserts in the world, they have precipitation till 50 centimeters annually. But still, that precipitated water may not be resulting in what large vegetation as such. When talk about desert itself is a vegetation. The type of vegetation itself, we call them as what? Desert vegetation. Most of the time, you will be having the succulent plants. Okay, right. Whatever it is the case, right? Somewhere you have a vegetation, very minimal vegetation, very minimal vegetation. Okay, you call it as what? Desert. Okay, though deserts are found in different places of the world, the concentration of tropical deserts are confined to a particular location. What is that particular location? The western side of the continents in the tropical latitudes. Somewhere indirectly, I have hinted. Somewhere I've just connected the statement. Okay, right. You have plenty of, say, for example, deserts, but particularly you find that these tropical deserts are confined to what? The western side of the continent. Okay, now I'm trying to answer the first part of the question. What is the first part of the question? What are the different factors that results in the desert formation? That's the first part of the question. Okay. So directly I'm just shooting the bullseye. The different factors that facilitates the formation of these deserts are the three very important factors are there. Number one, more than cold current, right? Because we are talking about currents, I talked about the cold current, but more than cold current, it is all about the perennial effectivity of offshore trade winds. What is this offshore trade wind? See, for example, somewhere you look at the statement, almost all the tropical deserts are located on the west coast of the continent. But to be very, very precise, the western side of continent, but in tropical latitudes. What is tropical latitudes? The region that lies between Tropic of Cancer and Capricorn. So most of these deserts will be finding they are located between 30-degree latitude and 20-degree latitude. Right? Most of them, you are there in the western side of the continent. Right? Assume that this is the land, this is the place where I'll be having what? Desert. Okay. Western side of the continent as such. Okay. Now see, only thing is that I have to understand, right? Why exactly this place has become a desert? See, for example, number one, if I just talk about this, right, the western side, right, somewhere around 30-degree to 20-degree, right? You're there on the western side of the continent. This is the place where I have a desert. See, if you ask me, what is the planetary wind which has its effect here? We call them as a trade wind. And trade wind is an easterly wind. If you're there in another hemisphere, trade wind from subtropical high to equatorial low it flows. Okay, right? Normally they flow in what? Northeastern direction. Okay, northeastern direction. Already you are there in the western side of the continent. So you are there in the western side of the continent. One side it is land and one side it is what? Ocean, sea. Right? Either I call them as sea or ocean. Okay. Now this region comes under the influence of what? Trade wind. And see, my dear friends, see the nature of this trade. This is northeastern trade. But if you ask me what exactly is the nature of this wind is an offshore wind. The two, this wind has its effectivity throughout the year, perennial effectivity. So it means what? This region comes under the influence of offshore trade winds throughout the year. So throughout the year, I'll be having a wind which is flowing from land to sea, right? Any offshore wind will be a dry wind. Okay. The avenue of moisture being brought by this wind will be very, very less. So the primary reason why exactly this region has become desert, it is all because of perennial effectivity of offshore trade. Number two, equally important, desert is a region of a high pressure. It is very hard to believe that the desert is high pressure because what is the argument normally we take? We take that desert, tropical desert, are known for inducing, maybe I'll be having very hot condition. Hot condition is known for the formation of a low pressure, but you are calling it as high pressure. I'll tell you why. If I take the average temperature of a desert will be colder than the other places of the same latitude. Why? Because high temperature in desert is short-lived. Only during the high sun position, somewhere between 9 a.m. and 3 p.m., 4 p.m., something like that. Only somewhere around 6 to 8 hours in a day, right? Desert will be experiencing what? High temperature. High temperature. Right? Remaining, somewhere, if I just talk about remaining somewhere around, say for example, I can put it somewhere around 16 to 18 hours, I can take it. 16 to 18 hours. What I understand, desert will be experiencing what? Low temperature. Okay. So low temperature results in the creation of what? High pressure. That's the reason desert is more a region of what? High pressure. See, for example, even in India, we have a local wind called as Lu. This Lu is sourced from what? Thar desert. Only if Thar desert is a high pressure, right? I can have a wind sourced from there. Low pressure will be a destination. Only high pressure will be what? Source. If I take globally, Harmattan, wind Siraku, right? Winds like Kamsin, right? All this wind, they are sourced from what? Saharan desert. Only if Saharan desert becomes an example of high pressure, only then the wind can be sourced, right? So what I just want to tell you, the high temperature in desert is short-lived. What is more permanent? Because deserts during the night time is very cold, right? So somewhere I understand what is more permanent in desert is what? High pressure. And high pressure, again, if you ask me, high pressure is known for what? Dry condition. See, offshore wind is also known for what? Dry condition. High pressure is also known for what? Dry condition. Okay. And again, I understand most of these deserts along the coastline, there comes the influence of what? Cold ocean currents. Again, I know cold ocean current again induces what? Dry condition. See, offshore wind inducing dry condition. Presence of high pressure is again using a, say for example, inducing dry condition. Cold ocean current is also inducing what? Dry condition. How many dry condition? All this dry condition, if you put it together, obviously this place will become what? Desert. Okay. So these are the three very important factors, right, which generally makes or right, which has made or which has resulted in the formation of what? Deserts. Okay. So the first part of the question what we have answered. What are the different factors that resulted in the desert formation? Three factors. Somewhere, depending upon the word limit, I can explain these three factors in detail if it is needed. Okay, right. Now, talking about Aravali. Aravali. Why? Okay, sorry. Talking about Thar desert. Right? Also explain the reason for Thar being a desert. See, Thar is not located in the western side of the continent, but Thar is located in the western side of the country, but not the continent as such. Now, here, why Thar is a desert, if you ask me, I would say Thar has become a desert is all because of what? Aravali as a mountain. I'll tell you why. Because the single largest source of precipitation for entire India is southwest monsoon. What? The ongoing southwest monsoon. Okay. Southwest monsoon has different branches. We have this Arabian Sea branch, and we do have this Bay of Bengal branch, which will be entering from what? The Bay of Bengal side. Okay, I'll be having different branches. Bay of Bengal branch itself, I have three branches, right? We call them as what? Utkal branch. We call them as what? Meghalayan branch. We call them as what? Myanmar or Arunachal branch. Okay. Again, Arabian Sea branch, I have three branches, right? I have the Sahyadri branch, that is Western Ghats branch, the Central Indian branch, and the branch what exactly you are seeing, we call them as what? Kathiawar branch, because this almost enters through this Kathiawar peninsula. Okay. It enters through Kathiawar Peninsula. Now here what happens? Southwest monsoon is the single largest, say for example, source of precipitation for entire India, because I understand Southwest monsoon almost covers a 90 percentage of the land, and somewhere it yields somewhere nearly 75 percentage of annual precipitation. Single largest source of precipitation, right? Now here what happens, my dear friends? See the moment when I talk about this southwest monsoon entering India, somewhere when I talk about the movement of this wind and the orientation of Aravali, both are parallel to each other. So here what I understand, Aravali fails to act as an orographic barrier. Only if a mountain is somewhere placed perpendicular to the movement of a wind, right? Something like Western Ghats, right? If I just talk about Western Ghats, same image I can take it. Say, for example, when I talk about Western Ghats, assume that I'm talking about Western Ghats. If this Western Ghats is there, right? Now, if it is Western Ghats, what I understand, the same moment, if I just take it, I understand, say, for example, this Western Ghat act as the orographic barrier, act as an orographic barrier. They lie perpendicular to the movement of this wind. Okay. But when I talk about Aravali, Aravali do not act as an orographic barrier. See, only if I have a mountain and using the slope of a mountain, if the air mass raises, right, the air mass will become saturated, right, or supersaturated, and eventually it goes for condensation. It will be resulting in what? Precipitation. Rise of an air mass. Even front we have taken it. Why cold front is known for inducing bad weather effectivity, right? Squall line. If you ask me, because the rate of rise is very high. More is the rise, more is the condensation, more is the precipitation. But here, since Aravali is placed parallel to the movement of southwest monsoon, Aravali fails to act as an orographic barrier. Somewhere there is a failure in the condensation process that is resulted. And what is very interesting, the same wind which passes the western Rajasthan, almost say for example, when it hits Himachal Pradesh, the same wind which almost fails to yield that precipitation in western Rajasthan and making the western Rajasthan, right, or Thar as a desert, is the same wind which has resulted in cloudburst in what? Himachal Pradesh. So, wind as such is not dry. See, relative difference between the moisture holding capacity of Arabian Sea branch and Bay of Bengal branch can be there. But what is very important is what? The orographic barrier. The same wind when it strikes Himalayan region, right? When the rate of rise is very high, it results in what? Cloudburst. Okay. So, nutshell, if you ask me, why Thar has become a desert, it is all because of orientation of Aravali. Aravali's orientation and the movement of southwest monsoons are parallel to each other. As the case, Aravali fails to act as an orographic barrier. Largely, these winds, almost say for example, right, they are just a passing winds. Am I right? They are passing clouds in the western Rajasthan as such. Okay. So that is the reason why exactly western Rajasthan has become what? Desert. Now you may ask me a question. Okay, of course. If it is a concept, you can ask me a question. But again, you may wonder then why exactly the eastern Rajasthan is not experiencing the desert-like condition? Because I understand eastern Rajasthan to some extent receives precipitation also from what? Bay of Bengal branch. Bay of Bengal branch. Utkal branch to be very, very precise. Okay. Even this Bay of Bengal branch, by the time it reaches the other side or it reaches this region, it becomes relatively what? Dry. Okay. Right, my dear friends, these are some of the questions what we have taken for today's discussion. Okay. The rest of it, I think two more sessions we have it, right? We'll try to cover the larger aspects, including some of the current related issues. Most of the things what we have taken, the concept is related with current events as such. Okay. Right, my dear friends. So wishing you all the best, all the very best, and good luck for your preparation. Thank you and God bless.